Okay, now in this section we're going to try to figure out what a recursive formula is and how I can use such a thing to generate the first 6 numbers in a sequence. Not a series, but a sequence, okay? Well, let's talk about that. A recursive formula has 2 parts. The first part of the recursive formula is the start. It tells you the start of a sequence, okay? That's what the first part of a recursive formula is. And the second part is the recursive equation, or what happens from that, what changes from the beginning, that starting value. So we have a start and then a change, a start and a change. I can almost think of this recursive equation as the change, or how something changes. Okay, that is repeatedly applied over the same process over and over again. Okay, so I got an example right down here. Check out this example. We have t sub 1 equals 4. Now that's what that is. This is your start that I was talking about. And the t sub n equals t sub n minus 1 plus 5. This is your change, or this is how it changes from one thing to the next. And we're going to use these 2 things to figure out the first 6 terms of a sequence using this recursive formula. Now, we know the first term is given to us. T sub 1 is equal to 4. That's our first term. So we can, let's just put it right here, 4. That's the first term. Now we want to find the next term in the sequence. Now what you have to do to find the next term is you've got to take this 4, and you're going to plug it in for the t sub n minus 1. So we got 3 times 4, and then plus 5. Well, 3 times 4 plus 5 is 12 plus 5. 12 plus 5 is 17. So the next term is equal to 17. So notice this is like, think of this as your next term, and this t sub n minus 1 is your now. So right now we were at 4, and the next is by plugging in the now into this formula to get the next, okay? So our next one, our t sub 2, is equal to 17. So we put a 17 in there. And then we repeat this process again. So we'll delete this out, and we'll put down, we're going to take this 17 in, we're going to put it in for our now. So we have 3 times 17 plus 5. 3 times 17 is 30, 51. 51 plus 5 is equal to 56. So our now, or our next term would be 56. Okay, that's the first 3. Okay, now let's do another one. It looks like this one's going to grow really fast by a factor of 3 each time. Now we're going to take this 56, plug it in for this t sub n minus 1. So we have 3 times 56 plus 5. 3 times 56 is 150 plus another 18, so 168 plus 5. 168 plus 5 is 173. So our next one is 173. Okay. Now we're going to put that one in there and find our next term. So now we'll take the 173, plug it in here. So we have 3 times 173 plus 5. Now this is 3 times 100, that's 300. 3 times 7, that's 200, so this is 510. But now 3 times 3 adds 9 to that, so that's 519. Everyone see what I kind of did there? Pretty sure this is 519. 519. Hopefully I didn't screw up on that. Plus 5. 519 plus 5 is 524. So our next term is 524. And so that's 1, 2, 3, 4, 5 term. Oh, we need one more. Holy cow. Okay. So we're going to take the 524 and we're going to plug that in there. This is our last one. Take the 524, plug it in for our now. So we got 3 times 524 plus 5. This is equal to 1570. 1572 plus 5. 1572 plus 5 is 1577. And so our 6th and final term is 1577. So just to kind of put this in a nice clean order, these are our terms right here: 4, 17, 56, 173, 524, and 1577. Now, everyone, if I made a error while I was doing this, I apologize. But you get the idea. This is how you can use a recursive formula to generate the first 6 terms of a geometric sequence.